Hello, this is Bahman Karimi. I'm mathematics teacher at Canada Cambridge Academy. Today I'm going to talk about transformation of a function. This video is highly recommended for grade 11 students. Please stay with me for 15 minutes. We'll start off with our learning goals for today's session and then success criteria. I'm going to explain to you the concept of transformation, and then I'm going to solve one or two examples for you, and then I will end up this session with providing some question for you. Enjoy your math class. Canada Cambridge Academy. Teacher Bahman Karimi. Today, learning goals. Transformation of functions. Transformation. Sketching a transformed function. Success criteria. I can explain transformation. I can solve related problems. Okay. When we deal with transformation, usually we have two functions. We have a parent function as a y fx, and also we would have a transformed function. General form for transform function is y is af k x minus d plus c. All we need to know as a grade 11 student or as a grade 12 student, we should know how a, k, c, and d can affect a function. Any point on a parent function, I will call this function as a parent function. I will call this function as a transformed function. Please notice the difference. Any point on, for instance, A on parent function, its image on transformed function is gonna be x over k plus d and ay plus c. Yeah, that's all the point. But before moving forward, we have to have kind of sense about the roles of AK. answer. K and D are related to X values. A and C works with Y values. Clear and to the point instruction. As a student, maybe someone asks if A is positive or A is negative, A is greater than 1, A is less than 1. How that works? Stay with me. I would say for A greater than 0, we're going to have vertical stretch. A between 0 and 1, vertical compression. For A less than 0, vertical is much better to say reflection about x-axis. Okay, so far so good. What about C greater than 0? Translation to the up. C less than 0. Translation to the down. Okay, what about K? What about D? I'm gonna have for you here. K. As you see, all X values divided by K. K greater than 1, horizontal compression. K less than 1, horizontal stretch. K less than 0, reflection in y-axis. What about D? For D greater than 0, translation to the right. And for D less than 0, translation to the left. I'm going to have a short review on this because that's the core of this concept. Two functions, y(f(x) as a parent function and also y(a) f kx minus t plus c as a transform function. Any point on y(f(x), we call x and y, will change to x over k plus t ay plus c. A greater than 0, we're going to have vertical stretch. A between 0 and 1, vertical compression. A less than 0, reflection about x-axis. C greater than 0, translation to the up. C less than 0, translation to the down. K greater than 1, horizontal compression. K between 0 and 1. It's much better to say between 0 and 1. Horizontal stretch, K less than 0, reflection in y-axis. For D greater than 0, you're going to have translation to the right, and D less than 0, you're going to have translation to the left. Okay, by having this knowledge now, it's very easy to solve all questions in grade 11, grade 12 related to transformation. I'm gonna do one for you. For instance, we have y root x as a parent function, y3 2x minus d, 2x say minus 4 plus 4. Okay, we know how root x looks like. Now we're gonna have transformed one. I suggest start with table of data, x here, y here, for parent function 0, 0, 1, 1, 4, 2, 9, 3. Corresponding points on transform function. X changes to x over k plus d, y changes ay plus c. Then first you should know what are the a, k, c, d. A is going to be 3 in here, k is 2, d is 4, c is 4. X, say 0, substitute over k over 2 plus d plus 4. Keep in mind, we have negative in formula. When you have negative, just keep d as is, 4. A, what is A? 3. What is Y? 0 plus C plus 4. Then summarize here, 0, 0, change to what? 4 and, see, 0 over 2, 0, and then 4 and 4. We figure out 1 point. Second point, 1 over 2 plus 4, say 4.5. In here, 3. 1 plus 4, say 7. 1 and 1, corresponding point would be 4.5 and 7. Then 4 over 2 plus 4, 6. 3 over 2 plus 4, 10. Make sense? In here, 4 and 2, 6 and 10. In here, 9 over 2 plus 4, 8.5. 3 times 3 plus 4, 13, yeah? Because 9 plus 4 makes what? 13. Then you have 8.5 and, I mean, say 9 and 3. Change to 8.5 and 13. That's all we need to know. Now we have 4 points. We are good to go. We know how a square root function looks like. X in here, y in here. That's better to have both functions on the same Cartesian system to understand concept of transformation much better. This one is going to be, this is root x, okay? The blue one, root x, I will write here. 0, 0, change to 4 and 4. For example, this is 4, this is 9, for instance. This is, say, 4, then this is 2. It's better to have a bit accurate graph. Then, for example, say this is 3. Yeah. Then this is 4 and 2, like this. Then I'm gonna have something like this. Okay, let me try for a bit better. Here you go. I did it. Now, 0, 0, 4 and 4. 4 and 4, a bit higher. I'm gonna get rid of this part. Four and 4 is here, for instance, and then 4.5 and 7, say this point, and then say 6 and 10, this point, and then 8.5 and 13. Yeah, then 8.5 and 13. Then I'm gonna have different color. This is y3 2x minus 4. Let me write here. 3 2 in here, x minus 4 plus 4. Okay, this is transform function. Your turn. Y is x squared, graph y, 3, 2x minus 4 squared plus 6. Y is sin x for trig or predicate function, y 3 sine 4 x minus 60 degrees. Thank you for watching this video. Please subscribe us. I wish all the best to you.